Okay, so we are now on our last topic, which is the moment distribution method. Okay, so before proceeding and giving you a sample computation, let us first have these concepts that we have to learn. No? So one is the sign convention. Okay, so the sign convention for this method is the same sign convention that we use in the slope deflection equation. Okay, so clockwise moment that act on the member is considered positive, whereas the counterclockwise moment is negative. Okay, so timan-an na to ni. Okay, then we have the fixed end moments. Okay, so the formulas that we use in the SDA also apply in the moment distribution method. Okay, so I hope you have memorized all those formulas. Pero anyway, during examinations, I know that you can open your books. So, no need to memorize, di ba? Okay, so next is the member stiffness factor. Okay, so here we are given member AB, which is pinned at A and fixed at B. So if a moment is applied at A, the member will rotate equivalent to theta A, and another moment is carried over to the other end, let's say MBA prime. So by conjugate B method, we can determine MAB, which is equal to 4EI over L theta A. Okay, now this term, which is enclosed in parentheses, is now referred to as the stiffness factor, K equal to 4EI over L. And this stiffness factor at A is defined as the amount of moment M required to rotate the end A of the beam theta A, which is equal to 1 radian. Okay, so that is the definition of the stiffness factor. Okay, so we have also what we call the joint stiffness factor. Now, there are structures wherein members, two or more members meet at a joint. So say for example, we have this frame, no? So we have DAB AC. Okay, so member DA, AB, and AC meet at a common point at A. Okay, so let's say the stiffness factor for member DA is KAD equal to 1000, and the stiffness factor for AB, let's say equivalent to 2000, and the stiffness factor for AC is equal to 3000. So giunsa man ni siya pag-solve using this formula, no? Our stiffness factor, which is equivalent to 4EI over L. Okay, so the joint stiffness factor is the sum of all the stiffness factor of the members meeting at the joint. Okay, so the stiffness factor for joint A is the sum of KAD plus KAB plus KAC. So if we sum this up, that is equivalent to 6,000. Okay, so another concept is what we call the distribution factor. Okay, so the distribution factor is equal to K over summation of K. So for this joint, the distribution factor for AD is equal to the ratio of its distribution factor over the summation of the distribution factor of the members meeting at the joint. Okay, so we have this example, no? So the distribution factor of AD is equal to KAD over the summation of K of the members meeting at the joint. So yung joint stiffness is 6,000 man. So our DFAD is equal to 1,000, the K of the member over the summation. So 1,000 over 6,000, so that is 1/6. And the distribution factor for AB is equal to 2,000 over 6,000 or 1/3. And for AC is equal to 3,000 over 6,000 or 1/2. Okay? So those are the distribution factors of the members meeting at joint A. Okay. Now we have also what we call the relative stiffness. Now, mostly the members of the frame have the same modulus of elasticity. Okay? So, if they have the same modulus of elasticity, the common factor for A, which is K is equal to 4EI over L, no? Okay, now kung constant ang imong E, so in solving for the distribution factor here, it is K over summation of K, and K is 4EI over L, and the summation of K is also has a term 4EI over L, no? So mao nang makancel ra ang 4A, so we can rewrite the stiffness factor equivalent to I over L na laman. Okay. Then we have what we call the carryover factor. Okay. Now from our explanation earlier, MAB is equal to 4EI over L theta A. Okay. And MBA kanisija by conjugate beam method can be determined equal to 2EI over L theta A, no? So ang imong gibutang diri nga moment, which is equivalent to 4EI over L theta A, is carried over to the other end, equivalent to 2EI over L theta A. So meaning, ang imong moment diri sa fixed is divided by 2. So kung himuan nato nag expression, our MBA is equivalent to 1/2 of MAB. So kaniman MAB is 4EI theta A over L. Nya ang MBA is 2EI theta A over L. So meaning kaning MBA is 1/2 ani. So mao na makaingon ka nga MBA is equal to 1/2 of MAB. And this 1/2 here is called the carryover factor. Okay? Okay, so kanina humana din ni maura na sa number 6.